Hello, good day. Welcome to K2 Concept YouTube channel. And with you is Dave Kome. And today I'll be taking you on another journey into the world of algebra. And we're going to be explaining a concept known as the echelon form. And we're going to be using this concept to solve system of equations. And first, to start with, in order to use the echelon form, then we are to convert the system of equation into matrix form, that is using the concept of ax equal to b. Ax equals to b, where a is known as the coefficient of the unknown, then x is the matrix that contains all the unknowns, and we're having x1, x2, x3 as the unknown. Then b here is the constant on the right hand side. Take note of that. Now, our a from this problem will give us, we have seen 3 minus 2, 1, 1, 3 minus 2, 4 minus 1, 5. Then we have x, which is our unknown. And our unknown here will be x1, x2, x3. Then our b will be 2, 5, and 7. Take note of that. Now with this, to use the echelon form to solve this problem, we use what we call the augmented matrix. The augmented matrix is you combining the coefficient matrix and the constant on the right hand side, which will give us 3 minus 2, 1, 1, 3 minus 2, 4 minus 1, 5. Then you combine, you add the right hand side, which is 2, 5, 7. Now, you can be given a question to reduce a matrix to whole echelon form. Let's say matrix A. Then you have no issue. You don't need to combine with anything. You just reduce like that. The same way we are reducing this augmented matrix is the same concept you use to reduce any given matrix to what? Whole echelon form. Now, take note. To reduce a matrix to whole echelon form, you should know that we have what we call a pivot row and a pivot element. What are pivot rows? A pivot row is a row that have one or two rows below it. That's why it's called a pivot. That means it must be a pivot row because it's having a row, one or two below it. So we can see for 3 by 3 matrix, we have only 2 pivot rows, which is row 1 and row 2. Row 3 cannot be a pivot row because there's no row below row 3. So we start to reduce. The first thing, we select row 1 as our first pivot row. Then on the pivot row, the first non-negative is going to be our pivot element, and the first non-negative there is what? Is 3. I want to use 3 in a way that every element or entries below 3 will be turned 0. And how do we do that? We add 3 plus 1 and make sure that we can get a result called what? 0 at the end of the day. So 3 plus 1. We observe that 3 plus 1 will not give us 0. So the only way 3 plus 1 can be 0 is to add a scalar. And that is the concept of elementary row operation, which said interchange any two rows, multiply any row by a scalar, then add the result to another row. That's elementary row operation. So if you multiply this place by 3, it's not yet equal to 0. So your minus sign is always added to this place. If you have to introduce any minus, you add it to this part, but at this point must always be what? Positive. And we see that this will give us what? 0, which we can write minus the 3 here is for row 1 plus the scalar, then 1 here is for what? Row 2, and the 0 we are to get is to get a new row 2. Take note of that. If you do that, this is what you are going to obtain. The same thing, to solve for this other one, we said 3 plus 4. But 3 plus 4 will not give us 0. So we introduce 4 on this part here. Then we introduce 3 on this part here. Then we put minus here. So we have minus 12 plus 12 will give us 0, which will give us minus 4, which is a scalar, and 3 is the row 1, which is a pivot row, plus 3 is a scalar, then row 3 will give us new row 3, represented as R3 prime. Now to do that, we perform the operation. The only row that will remain fixed is a pivot row. Take note of that. Then every other one will change their form, because we are getting new row 2 and new row 3. And here becomes what? 0. If I apply this operation. Now to get this other one, it will be minus 2 and 3 using this operation. Then 1 and minus 2 using this operation. 2 and 5 using this operation. Then to get this other one will be 3 and 4, which we already know that it is equals to 0. Then minus 2 and minus 1 with this operation. 1 and 5 with this operation. Then 2 and 7 with this same operation. Applying the same thing there. If I have minus 2 minus row 1 is 2 minus 2. So minus 2 minus will give us plus 2, plus 3 into row 2 is 3. So at the end of the day, your answer here will give us what? 5. Minus row 1 here is what? 1. That's minus 1. Plus 3, row 2 is what? Minus 2, which will give us what there? Minus 6. Minus 1 minus 6 is what? Minus 7. The same thing, 2 will be what? Minus 2 plus 3 times 5 is what? 15. Minus 2 plus 15 will give us what there? 13. I've gotten that of the row 2. Now we are going to the next row using row 1 and row 3 with the second operation, which is minus 4 row 1. Row 1 is minus 2, which is minus 4 times minus 2 will give us what? 8. Plus 3 times minus 1 will be what? Minus 3. So 8 minus 3 here will give us what here? 5. 1 and 5. 1 into this is what? Minus 4 times 1, which is minus 4. Plus 3 into 5 will be what? 15. Minus 4 plus 15 will give us 11. Then lastly, 2 into this will be what? Minus 8. Plus 3 times 7, which is 27. Then minus 8. If you subtract minus 8 from if you subtract minus 8 from 21, minus 8 from 21, we are going to have minus 8 from 21. If you subtract minus 8 from 21, your result will be, I said we are going to have something like minus 8 plus 21. So if you do this very well, at the end of the day, your result will become what? 13. 13 at this stage. Take note of this. You can decide to write all this out, or you might decide to do it. They understand what you are doing based on this operation. Minus 8 plus 21 will give us what? 13. Now we have solved that. The entry below the pivot elements are now 0. So we'll move on to the next pivot row. The next pivot row is now what? Row 2. And the pivot element there is what? 5. And we are told that any element below it must be equals to what? 0. And we are saying 5 plus 5. That's what we are saying there. To make this one 0 is 5 plus the number we want to make 0. But how do we make it 0? Is to introduce what? Minus here. Make it 0. So which means minus the first 5 is what? Row 2 plus row 3 will give us a new row 3 at this stage. So at this stage we observe something, and what we observe is that our row 1, which was initially a pivot row, cannot be changed. Now we're having a new pivot row, which is this, remains fixed, but only row 3 will be the row that will change, because that's the only operation we performed. So here it's still 0, it cannot be changed also. Now to get this one, minus 5 and 5, we have said this one will give us what? 0. Then minus 5 into minus 7 will give us 35. Minus 5 into minus 7 will give us what? Sorry, this will be minus row 2 rather, and row 2 is minus 7 plus 11, which will give us 7 plus 11. At the end of the answer here is what? 18. And here is minus 13 plus this. This one is also going to give us what here? 0 at the end of the day. So which means at this stage, we have been able to reduce this matrix to what we call the whole echelon form. Then the next thing is to transform. We say the system of equation to this problem, the system of equation will be, you write it again, 3x1 minus 2x2 plus x1 equals to 2. 5x2 minus 7x2, x3 equals to 13. Then 18. Now we have 18x2, x3 rather, equals to 0. Now using back substitution, we can call equation 3, equation 2, and equation 1. Then using back substitution, we observe that 18 x3 equals to 0, then x3 equals to 0. Now substitute this answer, you just obtain into equation 2. And what's our equation 2? Our equation 2 is already given to us. Equation 2 is 5x2. Equation 2 is 5x2 minus 7x3 equals to 13. So 5x2 minus x3 was obtained as 0 equals to 13. 5x2 equals to 13. x2 equals to 13 over 5. Now substitute the values of x3 equals to 0 and x2 equal to 13 over 15 into equation 1 so that we can solve for x1. So 3x1 minus 2x2 plus x3 equal 2. Then 3x1 minus 2 into 13 over 5 plus 0 equals to 2. So we have 3x1 minus 26 over 5 equals to 2. Now if you solve this problem very well, make it linear, make this place linear, LCM is 5. Here will give us 5 times 3 will be 15 minus 26, 5 cancel out 5, then 5 times this is what? 10. So we have 15x1 equal to 10 plus 26. And at the end of the day, we're going to have 15x1 equal to 36. Then x1 will be 36 divided by 15. x1 will be, 3 can go here, 3 will give us what here? 12. Then 3 will be what? 5 here. So 12 over 5. So finally, our x1 is equals to 12 over 5. Our x2 is equals to 13 over 5. And our x3 equal to 0. Now, if you observe that this system of equation was solved using the echelon form. So a problem can be given to us to reduce this matrix to echelon form. Then we don't need to combine it with the augmented matrix. Now, thank you for watching. I am Dave Come. Don't forget to subscribe, like, comment, and also share the videos with your loved ones so that it can be of good and a great benefit to them also. Join me again in my next video. I'm going to be explaining how to reduce a matrix on its own to echelon form. Thank you.